Okay, in this lesson we're going to look at a couple of properties of pairs of lines. Before I start, I'm just going to look at a couple of quick exercises. The first one says, on the grid below, draw two lines for which m is equal to 2/3. Remember, m is the slope, so this is saying the slope is 2/3. And remember, slope we define as being the rise over the run, which is the change in the y divided by the change in the x. Okay, so that's what slope is. So the slope of 2/3 means a run of 3 and a rise of 2. Every time there's a horizontal change of 3 units, there's a vertical change of 2 units. Remember, vertical change over horizontal change. So every time there's a horizontal change of 3 units, positive, there's a vertical change of positive 2. And in our context, a positive horizontal change means going to the right, a positive vertical change means going upwards. So in order to draw these two kind of lines, what I want to do is I want to think about what's going to happen here. I want to select a starting point and draw my line. So maybe for the first line, I might just select right down here at this corner point, right down the bottom left hand corner is the starting point. I want to run across 3 because the slope is 2/3, run of 3. And I want to rise up 2, 1, 2. And there's my line. I can draw my line with a ruler through there. Okay, at the moment it's a line segment actually because it has two end points. A line extends infinitely in both directions, so a little arrow on there at each end will make that a line, saying that that extends infinitely in both directions. Obviously we cannot draw things that are infinitely long, so we represent them with arrows. So I just looked at the run of 3, rise of 2. Okay, so if I look at this line, every time there's a run of 3, there's a rise of 2. And that goes on forever and ever, behaving in that same way. It's a line. I want to draw the second line. I'm going to do it in exactly the same way. Maybe I might start here at my initial point. Start anywhere really, as long as you can fit it in. And I'm going to run 1, 2, 3 and rise 1, 2. And that's going to extend there infinitely far. Okay, I'm going to just put arrows at the end here just to show that they go on forever and ever. And note with this one, every time it runs 3, it rises 2. So one kind of effect of that, because they both have the same run and same rise, those lines are never going to get any closer to each other. They're going to stay that distance away from each other forever and ever. They'll never meet. And lines like that are called parallel lines. And if I call the blue line L1, I'll call the black line maybe L2. Lowercase letter to name your line. What I can say here is that L1 is parallel to L2. Parallel means running in exactly the same direction with the same slope. They will never meet. And the reason they're parallel is because their slopes are equal. So parallel lines have equal slopes. Two lines are parallel if and only if their slopes are equal. We've got to remember that. Okay? And of course, not just for 2/3, practice drawing out some other slopes. But you'll always find you'll get a pair of parallel lines. Second quick exercise, I want to draw two lines. One such that its slope is 2/3, just like before. So I'll start with that. Slope of 2/3, pick my starting point down here maybe. Slope of 2/3 means run 3, 1, 2, 3, and rise 2, 1, 2. So there's my line. I'm going to just extend it to the end of the grid. And that line is running on forever and ever. And slope 2 is equal to the negative of 1 over m1. This means we call that the negative reciprocal. So if you type into your calculator -1 over 2/3, which is m1, your calculator will tell you that -1 divided by 2/3 is actually -3 over 2. It's the negative reciprocal of the fraction 2/3. Negative because the sign has changed, reciprocal because it's flipped. So I want to draw a line that has a slope of -3 over 2. One thing I'm going to think about that, I'm going to think about that as -3 on the top and 2 on the bottom. Remember, that's rise over run. So run of 2, a rise of -3. Well, a rise of -3 means it's actually a fall. It's coming down the page. So if I look at a run of 2, starting from this point, out 2, and then a rise of -3, we're moving down 1, 2, 3 to there. And if I want to go and draw that line now, I'll change the color now in a second. So that's what a line with a slope of -3 over 2 looks like. Again, it's a line as opposed to a segment, so it has no end points. It runs forever in both directions. And you can see clearly they're not parallel. Those two lines are definitely not parallel. So I want to think about these lines for a second. And let me just label them here, L1 and L2. Sorry, I'm actually going to have labeled them incorrectly. Why? Because M1 is 2/3. So the slope that is 2/3 has to be line 1. And M2 is -3 over 2. So the slope with the negative slope has to be line 2. I just want to investigate something here. So what I'm going to do, I'm just going to take a little set square here I have stored up in the corner. I'm just going to take it down. I'm just going to measure that angle where those two lines meet. And I'm hoping you'll see there, if you do this at home or take your protractor or something, that they actually meet at a 90-degree angle. They meet at right angles. And when two lines meet at right angles, we say they're perpendicular lines. And we say, you know, line 1 is perpendicular to, well, there's my symbol for is perpendicular to line 2. Reason, since the slope of line 1 is equal to the negative reciprocal of the slope of line 2. Or let me write it the other way. The slope of line 2 is equal to the negative reciprocal of line 1. Of course, the slope of line 1 is also equal to the negative reciprocal of line 2. Okay, but we know that M2 is equal to -1 over M1, so that's the way I've written it. So perpendicular lines, slopes are negative reciprocals of each other. Also, you know, by just changing the subject of this formula here, making -1 the formula, -1 will equal to the slope of line 1 multiplied by the slope of line 2. So that's also an important thing to remember. So -1, if I multiply the slopes of two perpendicular lines, I should get -1. Okay, so quick exercise, really important to know that. Okay, let me just get rid of my set square at this stage. So I want to talk about two important properties of perpendicular and parallel lines. Well, two lines are parallel if their slopes are equal, and you know, you're expected to learn these things by heart and know them. I mean, you learn them by heart not by sitting down and repeating them 1,000 times, but by making sure you understand them. Okay? To phrase it properly, maybe then you do have to repeat it a few times, but make sure you understand what they're saying. So two lines are parallel if and only if their slopes are equal. Two lines are perpendicular if and only if their slopes have a product of -1. Another way to say that is two lines are perpendicular if and only if their slopes are negative reciprocals of each other. So I'm going to just fill out this table. It says the slope of a line is 2. Well, I wonder, could you just pause the video and maybe try to fill this out yourself? I'm going to fill it out now at a reasonable pace. We said the slope of any parallel line will be equal to the slope of the original line. So if the slope of a line is 2, the slope of any parallel line is going to be 2. If the slope of a line is 3, the slope of any parallel line is going to be 3. If the slope of a line is negative 5, well, any parallel line will also have a slope of negative 5. A line with a slope of a half will be parallel to any other line with a slope of a half. A line with a slope of negative 3/5 will be parallel to any other line with a slope of negative 3/5. Okay? A line with a slope of 0 will be parallel to any other line with a slope of 0. Okay? A couple of things to note. What do all these numbers mean? Well, positive slopes means it's moving upwards, that the line is rising as we move from left to right. Negative slope means the line is falling as we move from left to right. Okay, we say a positive slope, it's increasing. Negative slope means it's decreasing. So slope of 2, run of 1, rise of 2 would look like something like that. Slope of 3 would be a bit steeper. Slope of negative 5 would be a very steep negative line. Slope of a half would be, a run of 2 or rise of 1. It would be less steep, something like that. Slope of negative 3/5, a run of 5, fall of negative 3, something like that. Slope of 0 is a horizontal line. And that's an important one to remember. People often forget that. Slope of 0 means the line is horizontal. Okay, I want to think about any perpendicular line. Well, we said that two lines are perpendicular if and only if their slopes are negative reciprocals of each other. So we said to find the negative reciprocal of a line is we just take negative 1 divided by, to find the negative reciprocal of any number, I should say, we take negative 1 and divide it by that number. So the slope of the second line will be negative 1 divided by the slope of the first line. Or, of course, that means also that the slope of the first line will be negative 1 divided by the slope of the second line. So the slope of any line perpendicular to 2 will be negative 1 divided by 2, which is negative a half. The slope of any line perpendicular to a line with a slope of 3, well, the slope of any perpendicular line will be negative 1 divided by 3. If the slope of a line is negative 5, well, the slope of any perpendicular line will be negative 1 divided by negative 5. Notice that's positive because it's negative divided by negative 1/5. Let's go tidy that up a little bit. Positive 1/5. If the slope of a line is 1/2, well, the slope of any perpendicular line will be negative 1 divided by 1/2, which will be negative 2. We just flip the fraction, change the sign. Flip 1 over 2, we get 2 over 1, which is 2. Change the sign to negative. If the slope of a line is negative 3/5, the slope of any perpendicular line, change the sign to positive, flip the fraction, is going to be 5/3. Okay? Perpendicular lines. So the slope of any line is 0. That line is parallel. This negative reciprocal of 0 is actually undefined. Negative 1 divided by 0 is undefined. What does that mean? Well, if the line is horizontal, any perpendicular line will be vertical, and vertical lines have an undefined slope. Why? If I take any 2 points on a vertical line, the horizontal change between them is 0, and we cannot divide by 0. So parallel and perpendicular lines, make sure you know that, and practice, practice, practice.